This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the Uptime Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's show, we've got a great lineup, also an amazing guest. Nick Gaudern, who is the Chief Technical Officer from PowerCurve, is back on with us today. He's going to chat later on in the show about vortex generators and some other blade aerodynamic upgrades. He's a whiz when it comes to aerodynamics, so we're excited to have him and his expertise back on the show. Before that, we'll talk a little bit about Equinor, some of their sea drone technology, checking on wind farms and the aquatic wildlife beneath. We'll talk about migratory birds, some new legislation, or really just the law looks like it's changing again here in the U.S. So we'll talk about some of the implications there for wind turbines, birds. And then after our interview, we'll talk Germany. There was a Nordex wind turbine collapse recently. Not much on it as far as causes. We'll talk about that sort of as an industry-wide issue, like why do we not know some of these things? And some of it seems like it's kept kind of close to the vest. We'll also talk about blackouts potentially in Germany. Their electricity supplies seem tenuous at times, and some interesting advertisements have been sort of driving that point home with their own people. And lastly, we'll talk about a U.S. congressman proposing some funding programs for wind and solar here in the U.S. So first, let's start with Equinor. Alan, you seem pretty keen on this technology. They have been putting out their sea drone, running around collecting a bunch of data. So tell us, Alan, what's some of the stuff that they're looking for here on these offshore wind farms?
Well, they're looking to see what the sea life is right now before they start investing in a lot of offshore wind, and to try to get a baseline for what the sea life is and what the vegetation is and what the migratory patterns are in some cases. So they're basically putting out these, looks like little boat drones. They're about 6 feet, 2 meters long, and they have a solar panel on them. They're self-propelled, and they relay data back to shore, but they're just tracking the wildlife in the area. It's very similar to that we would do on land when we put wind turbines on land. We track the migratory birds, we track the wildlife, we make sure that where we site these wind turbines, for the most part, it's not going to cause a problem with the wildlife. So this is very interesting because we haven't seen it much, particularly in the United States, and we're destined to put up literally thousands of turbines out in the ocean in a place near me where there's a lot of sea life, and we don't have that sort of data. So it's interesting that the Europeans are already way ahead of us. And Rosemary, do you see that same thing happening down in Australia as offshore wind starts to come in your area too?
Well, offshore wind hasn't come to Australia yet. There's quite a few projects that are in development, and I think that we are going to get some announcements in the next year or two, but probably we've got nothing to monitor currently, so it wouldn't be the right place to do it. But I think it is good to get as much information as possible. I think the community is always really concerned about animal life and how it's affected by new developments. So if you can, know the impacts ahead of time, you're less likely to be reacting to something bad that happened after you install, a $1 billion wind farm or something. So I like to see the technology making it easier to get more information.
Yeah, so this glider is interesting because it's a drone, but it has a glider component, so it can just be pushed around via the wind. So that's pretty interesting. And then obviously it also has some solar panels on top of it. So, it's got that autonomous component to it where it's a little bit self-powered and it can sort of putter around. And, I guess some of the things they're looking for our fluorescence of chlorophyll, other measurements that are just sort of saying, hey, how's the zooplankton? Are we forming an ecosystem down here where there's things for, fish to eat? And are we seeing like growth and like a bloom here? So, Alan, I mean, we've talked at length about sort of like these ecosystems where you could have a sea lab and this and that and the other thing. Really. It seems like kind of in that same vein where, hey, let's see what's going on so we can kind of like maybe they find some stuff and they're like, hey, we can cultivate this. Maybe if this stuff is happening, if we did this, this, and this, or restructured some of the structures underneath, you could always add things where maybe it encourages certain mussels or shellfish. I'm going to expose my lack of shellfish knowledge here, but you could probably extrapolate something from this data and say, hey, maybe if we do this, this, and this, we can get more of what we're already seeing.
Yeah, I think one of the interesting pieces is we don't know all that much about the migratory habits of fish. In large sense, we kind of do. Like we're learning now that sharks tend to travel the world, and so do whales. Like 20 years ago, we really didn't know that, so we started tagging them. I think we're going to run into that same situation when we start actually measuring wildlife, fish migration in places we haven't really looked. We're going to learn a lot about the sea life that we've never considered before, and that will come back around to change the way we design wind turbines. I guarantee you those first 100, 200 turbines get out there are not going to look exactly like the last 100 or 200 turbines that get placed out there because we're going to learn so much. And that's good. We should be doing that. Engineering-wise, we should be doing that.
So speaking of migration, here in the U.S., the Biden administration is moving to, again, make it illegal to accidentally kill migratory birds. So the Trump administration tried to roll this back. And Alan, you have some strong thoughts about this. So obviously, the way the U.S. is with the political sphere here in the news cycle, it's very like, oh, they did this and this was bad, and now this new administration. There's always like this, but it seems like there's both sides to this story. That maybe some of the reasons the Trump administration rolled this legislation back was maybe not all bad. Is that how you've kind of interpreted this?
If you read the press about it, it praises the Biden administration, it dumps on the Trump administration. It says the judge in the situation was tremendous in the decision to do X, Y, Z. And then you actually start reading the briefs and you start reading the memorandum that were generated, which started all this. And what has transpired was the original law about migratory wildlife birds in the United States, Mexico, Canada, and other countries was back in the early 1900s, 1915, 16, 17, 18, and the original law is from 1918. That birds are being killed by the tens of thousands or millions, and for their feathers or for their meat. So they're being harvested, right? So there's like hunters and out there just really decimating large quantities of bird species that they passed a law to stop that, to limit that. So there was this intent to sort of limit the amount of hunting and to control the hunting season, those kind of things. In the 1970s, that same 1918 law got interpreted as if you unintentionally kill a migratory bird, you could be held accountable for it. Now, what does that mean? Well, where that started really and got enforced was during an oil spill. So an oil tanker runs ashore, hits an iceberg, whatever it does, collides with another ship, starts leaking oil, and that comes on shore, and there's migratory birds there, so the oil company or the shipper can be held responsible for the bird deaths that happen there. Not intentional, not like going out and shooting birds, but just an effect of the actions that they took. Okay. So what the Trump administration was trying to resolve was the sort of unintentional bird death. And it really revolves around wind turbines on some level. If a bird runs into a wind turbine, the wind turbine operator is responsible. Well, they're not out there intentionally trying to kill birds. That's not the intent there. And so there was a lot of discussion about how to try to limit that or control that, like put some parameters around that. And so the Trump administration had put basically a memorandum together that said, hey, this law was never intended to deal with sort of single deaths of birds. It was dealt with in large quantities. And now what's happened is the Biden administration is saying, no, wind turbine operators are going to be responsible for those deaths. Now, I don't think that's necessarily a smart move in the United States, because the effect of that, and there's a consequence of that, and Rosemary, correct me if I'm wrong, but I think what will happen is in places where they have migratory bird deaths of increasing quantities, for whatever reason, the effect is that they're going to shut down those wind turbines to stop those penalties from being applied. And when they shut down those wind turbines, the cost of electricity will rise, like it did in Missouri recently with some bats that happened down there. Well, they stopped the wind turbines at night and asked for the ratepayers to pay more for electricity when they did it. I think that's going to become more common. And as we go offshore on northeast of the United States, on the shoreline where there's more migratory birds, that's just going to get amplified. Do you see that as a possible outcome?
Maybe, but I also, I mean, I'm a big bird lover. I go bird watching and everything. I own binoculars. It's true. So, you know, I probably
you admitted that. Okay.
Yeah, I have an app as well. I actually have two apps. I have the Australian Birds app and the European Birds app, and I log them. So, you know, like I'm a pretty serious bird watcher. So I do tend to come down on the side of birds. I mean, and biodiversity in general, it's actually, for me, that's my motivation for being in renewables industry. So I am okay with having some limitations on business to look after wildlife. And I'm also okay with electricity prices being a little higher. There's some weird things about the law, though, that I don't necessarily understand, because it's only about migratory birds. So I guess it would depend. Not every wind farm is killing migratory birds, that's for sure. Like there's certain places where they're affected more than others. I'm also surprised that you know that if I've got a study up here about bird deaths due to, you know, human causes. And in the US, you know, it's number 1, cats, number 2, building windows, number 3, automobiles, number 4, power lines, number 5, communication towers. And then, agricultural chemicals even is above, wind turbines. And so, and oil spills isn't on there at all, although it's probably mainland, like on land causes. So it's just weird because, yeah, so buildings and cars kill, you know, just vastly millions of times more birds, I think, actually. I'm looking at the numbers from cats, 2.4 billion per year in US, and wind turbines, 234,000. So, you know, like it's a massive difference in scale. So that's not migratory birds specifically, but I think that's interesting where we focus on bird deaths and where we don't, which always makes me feel like it's a bit of a beat up. But on the other hand, we also have environmental protection laws, right? When you have site a wind farm or you plan an oil extraction project, you do assess the environmental impacts already. As far as I know, we don't have some migratory bird law in Australia, but there's plenty of wind farms and any other kind of project that is, you know, stymied because of the effect on birds, and especially endangered birds, which is what I'm more concerned about. So to me, that's the right place to worry about birds. But I also just want to go back to the argument, you know, the difference between killing birds on purpose versus accidentally killing them. When it's a business, and I mean, you can reasonably foresee that if there's an oil spill, that there's going to be a lot of birds killed. You know that wind turbines can kill birds. If you don't, you know, if you put a wind farm up somewhere where you know that there's an endangered bird that is likely to be affected, I don't see a big difference between, we didn't put this wind farm in to kill the birds. I mean, you knew that they were going to be. So I definitely agree with siting appropriately so that you don't have, you know, big environmental impacts on any kind of endangered animal.
But this is a criminal penalty, right, Alan? I mean, what does that mean? A criminal penalty in this case?
I think it's defined as a misdemeanor, but it's like $15,000 per bird is what the penalty can be. So it adds up pretty quick. And I think if you're, I think most people that are operating wind turbines, most companies that are operating wind turbines are on the side of animals. I don't see them being against wildlife here. Like they're trying to do things that are cleaning the environment, reducing carbon monoxide, carbon dioxide, and part of that is an environmental concern too. And I just think you're just sort of hurting the people that are trying to help on some level. Like they know occasionally a bird's going to get near some things, and you really can't control where birds go. They're wildlife by definition. So if a bird does accidentally run into a wind turbine and die, I'm not sure does that force a legal proceeding? Does it need to?
Well, I mean, you start talking about what DAs will pursue. I mean, there's lots of stuff that they're like, we're not going to go after this case. So I don't think they're going to concern themselves with seven birds.
That's the problem.
But I think the laws are probably.
That's the problem, is that the Trump administration basically said that. And the Biden administration is saying, no, we're going to go, essentially, we're going to go after all those bad guys in the corporations.
But you're just assuming that. I mean, we don't know that, even if this is the new law, that they're going to be actually trying to prosecute a company for 5 birds or 8 birds. Well, plus, who's even out there monitoring that? I think this is probably more in place to say, hey, if there's something really big going on, now we have the legal ability to do something about it, where otherwise they wouldn't. Because, you're right. If they don't intend to, and it's they're not in a place where they anticipate killing, but then they start killing tens of thousands because something unforeseen happens and birds are going right through it, then they have a real big problem. And now they have the legal recourse to do something about it. Whereas if they just assume it's only going to be a bird or two and then it's not, then they don't have a recourse. So I feel like that's probably where this is going.
I hope you're right, Dan.
All right. Well, we're going to move on to our interview with Chief Technical Officer of PowerCurve, Nicholas Gaudern. So he is a blade aerodynamics expert. We've had him on the show before. He's awesome. So we're going to dive into all things vortex generators, gurney flaps, trailing edge serrations, and really get a deep dive on his perspective on the way aerodynamic power curve upgrades are changing in the industry. All right, Nick, thanks so much for coming back on the show. So let's get started. I think the first thing we want to cover here with you is, can you give us an explanation for those who don't maybe know what vortex generators are? So can you give us an overview of what they do and what they're made of and how they help improve AEP for wind turbines?
Yeah, absolutely. And thanks for having me back on. So a vortex generator fundamentally kind of does what it says on the tin. So it generates a vortex. But the important thing is how it does that and then what that vortex then does to the flow. So most devices that are sticking up into a flow, whether it be a little triangle or a little curve or a flat plate, it will create some kind of vortex. So you'll have a flow that hits it and you get a vortex roll over the top of it and then propagate downstream. So vortex generators you see on wind turbines, typically made from plastic, injection molded material, and they're typically triangular in shape, but you see a few variations of that. And then in a nutshell, why they are there is to increase the lift of a profile, an aerodynamic profile, and ideally to reduce the drag a little bit as well. So when you have air flowing over a surface, such as an aerofoil, the bit of air that is very close to the wall, we call the boundary layer. And this is where the flow goes from a zero velocity at the wall up to the free stream velocity. So it's where all the viscous effects go on. So the health of that boundary layer, this thin layer of flow, dictates how well an aerofoil performs. And in many cases, you may get situations where this boundary layer starts to peel off the surface from the trailing edge of the aerofoil. And we call this separation or stall, things like that. And when this starts to happen, it's bad for performance. So a vortex generator sits there to basically inject energy into the boundary layer. So to basically drag high energy fluid from away from the surface, pull it back down towards the surface into the boundary layer, give it more energy, basically restore the health of that boundary layer so that it can remain attached and energetic all of the way to the trailing edge. And by doing that, we can get a bit of a lift boost, we can delay stall and get some positive effects on the AEP.
So it seems like, it's pretty well known at this point that vortex generators, do a good job increasing AEP, like the cat's out of the bag. So, I mean, does every blade ship with these now right out of the factory? And if not, why not?
Yeah, that's a great question. So I think if you look in the last few years, the major manufacturers like Siemens, Vestas, GE, they are shipping with at least some vortex generators installed. And I say some because there's different kinds of vortex generators that sit in different parts of the blade. So what we'll do is we'll just think about those different styles you see. So if we break it down into regions of the blade, typically you'll see vortex generators on the leeward surface or the suction surface of the rotor, so the one that's behind the wind as you're looking at the rotor. And pretty much all of the big modern blades are going to see VGs installed on the suction surface down in the root region, so like inner 30 to 50% tops, something in that region. And the reason those vortex generators are there, and we can get into the details later, is because the flow quality in that part of the blade is generally pretty poor. The airfoils are really thick, they're not very good aerodynamically, and the VGs help performance. So it's kind of a no-brainer, it's well understood, it's in the literature, it's been tested, so they're put there. The outboard region of the blade is a little bit harder, because if the blade is really well designed and it's squeaky clean, then typically a vortex generator isn't going to be able to increase the performance by any meaningful amount when it's installed on that outer 50%. So manufacturers can typically be a little bit reluctant to put them there because you're not going to really see much happening. But those outboard VGs, they really come into their own whenever the blade is suboptimal. And by suboptimal, I mean it's got a bit of a bad paint job, the moulded surface isn't so good, it was made on a Friday night and it's been hand finished in not such a great way, and even more critically, is it dirty? Does it have bugs stuck to it? Is there leading edge erosion? So all those situations would benefit if there's a VG present. Then pressure VGs, pressure surface VGs, really very uncommon. So some of the really big blades, like 60, 70, 80 plus meter blades, we're now starting to see a few vortex generators appear on the pressure surface. And the reason for this is that because these airfoils are getting so thick for so far out on the blade to carry all the necessary loads, the curvatures are getting really quite steep. And whenever you have steep curvatures on a thick airfoil, you're more prone to trailing edge separation and stall, that thing we were talking about earlier. So that's why you might start to see some pressure surface VGs creeping in as the blades get longer and longer.
And so I want to stick with the idea that vortex generators can fix is probably the wrong word, but they can sort of fix aerodynamically some imperfections with the leading edge. So, we talked about the huge problems that they had in Texas this past year with icing. So it sounds like, vortex generators can really almost be like an insurance policy to, like, hey, if the blade starts to get erosion or, like you said, bugs or, dust, dirt, debris, ice, whatever, these are going to sort of like smooth that out and maintain the kind of standard performance that they would expect. Is that right?
Yeah, I think that's a really nice way of thinking about it. So if you look at the output power of a turbine over the year, it's all over the place, like it's spiking up and down. You may see some kind of patterns in there seasonally, like it's very, very variable. And if you have to take a mathematical term, if you look at like standard deviation of that power, it could be quite large. Whereas if you put on a vortex generator, typically you're going to see that band, that spread of powers reduce. So you get a narrower band of noise on your power. And the reason is because when you get these kind of suboptimal flow conditions, dirt, ice, bugs, erosion, they're the things that are adding that variability into the power. So anything you can do to minimize the variability in aerodynamic behavior, the better. So that's where your VGs come in. So we were talking about boundary layers earlier. Well, all of those things we've just listed, they hurt the boundary layer. They reduce the health of the boundary layer. They mean it's less likely to progress nicely to the trailing edge and remain fully attached. So any of those scenarios, a VG is going to help with, and it's just going to reduce a little bit of that variability because you're not going in and out of stall, for example.
So the placement of VGs and even the size of the vortex generators really matters. You're dealing with very complicated airflow movements over a rotating blade. The aerodynamics here is super critical to maximize your energy performance. So how do you determine where VGs are placed and what size of VGs to use.
Yeah, and that's absolutely critical, Alan, because if you put vortex generators in the wrong place or the wrong size, at best they're not going to work so well, right? They won't be optimal in how much energy they're adding. At worst, they might do nothing at all. They might even make your performance a little bit worse. And so it's very important to understand the individual blade design that you're putting these vortex generators on. So a CFD analysis, so computational fluid dynamics analysis, that's one of the key tools we have in our toolbox to understand how to optimize a vortex generator layout. So, as you say, these blades are big, they're moving quickly, there's a lot of three-dimensional flow. And these are hard things to understand and to design around. So if you take a model of your rotor and you put it through a CFD analysis, what it allows you to see is the details, particularly of that three-dimensional flow pattern. So how big is the stall region, what position on the chord is it, etc., etc. And by knowing these things, you can position your vortex generator array in a location that's going to be most beneficial to the flow. And that also links to the size as well. So as we go further out on the blade, every slice you take of the blade as you go further out has different aerodynamic characteristics, primarily driven by the fact that this is a rotating system. So every time you go out by 10 centimeters, whatever, the inflow velocity changes because it's a rotating system. So if the inflow velocity changes, then the angle of attack changes. If the angle of attack changes, then your flow changes. So it's absolutely essential to look at each part of the blade stage by stage, work out what the flow conditions are, and get that deep dive aerodynamic understanding. And then you can prescribe position, size, length of array to have the best effect.
So I feel like the word you just used, prescribe, is a good way to think of this. Whereas this isn't necessarily like an over the counter, like, hey, just go down to Target or Walmart or whatever and pick up, a couple boxes of vortex generators and slap them on, because they're not going to work the same as, like seeing someone again to do an analysis and say, this is what size, the configuration, and, and where we should put these to get the best effect.
Exactly. And it's, you're doing a disservice to your asset if you're not doing that. You're spending millions of dollars on a really complex, well-engineered piece of equipment. Why on earth would you just slap something on and hope? You have to go through a rigorous engineering approach to understand how to do this, and that's something that I personally spend a lot of time on.
And is this something that you see as far as like the retrofits go, that they're doing it? Is it any sort of? Is it 2 years after the blades? The turbines have been up and running. Is it 5 years? Is it 10 years? I mean, is there a certain time when this is recommended, or should they be installed from the get-go, and earlier is always better?
So I think, the blades vary so much. Like they vary in the quality of their manufacture, and they vary in where they're positioned, so the climatic conditions that the blades are facing. So my rule of thumb would be that any new blade should have vortex generators from day one on the inboard part of the blade. So it's very straightforward to understand the benefit of doing that. You can prove it quite nicely. But going back to what we said earlier, the outboard vortex generators, that's kind of takes a little bit of a different mindset. So you've got to have that understanding that I'm going to do something today because it makes sense and it's cheap to do it while it's on the ground or in the factory or whatever. But maybe it's not going to do a lot for a couple of years, but as soon as that blade starts to experience the real world wear and tear, then they're going to perform a benefit. And if you want to go and put something out on the blade as a retrofit, you've then obviously got to consider a bit of downtime. You've got to get some rope technicians on the blade. So it's all achievable. We do it all the time, but it's just a little bit harder and a little bit more expensive. So I think if I was a customer, I'd be talking to the OEM like, if there's not VGs on the blade now, why not? They should have a really good argument as to why they're not putting them on in the factory, especially down in the root region. I say the outboard, that's a little bit more of a nuanced conversation. So keep track of your blades, use drone inspections, look at the blades every year. How are they degrading? How does the surface look? So even if you don't have them on from the factory, if you have a good O&M routine, you've got great imagery, say particularly from a drone, you can get up nice and close. That helps you to decide, is now the time that I should really get these devices on if I don't have them already.
So, Nicholas, the OEMs, when they actually design a blade shape, they typically don't use CFD analysis, like a 3D analysis, to determine the aerodynamics. They use a blade element momentum model, which is a sort of a 2D approach to design the blade shape. And when you're talking about making 2%, 4% improvements in AEP, you really need to get to a 3D model and really look at particularly at the outer third of the blade very discreetly and get to a CFD. So a lot of times I think there's just a disconnect from the operator's standpoint. Like, why didn't the OEMs put VGs on my blade? Well, is it part because they're not really looking at that as part of the engineering analysis because they just don't do CFD, or what drives that internally?
Yeah, I think it's a really interesting point. So, the wind industry isn't very old in the grand scheme of things. Like, as an engineering discipline, it's relatively immature if you compare it to say aerospace. So a lot of these really high fidelity tools, they don't necessarily have the traction and the frequency of use that you might necessarily expect. And particularly 5-6 years ago, it was pretty expensive to do CFD simulations of a full blade. It's a big model; it needs a big computer to run on. But as you know, CPU costs, they've plummeted, and they keep plummeting. So these kind of analyses are much more possible now from a cost perspective. So the blade element momentum, it's not going away. It's like the bedrock of blade design, and the reason is it's incredibly computationally efficient, and it's really good. Like, it does great things, but if you're trying to squeeze every last drop of performance out of the rotor, it's just simply not good enough. There's too many assumptions in it and there's too many limitations. So when you move to CFD, you can take out all of these assumptions, particularly about 2D flow, that have been driving a lot of blade designs up until this point. So yeah, if you haven't done a CFD analysis of your blade, you're going to be missing important flow characteristics. And it's difficult to say how much some new blades have or haven't had CFD done, but my betting is 90% of the blades out in the world today have had little to no CFD work done on them. And that means you've got this optimization gap, you've got this potential, and that's where, PowerCurve comes in. We do a lot of work in this area, just taking that analysis to the next level and looking what may have been missed. What is that optimization gap, effectively? So,
Nicholas, PowerCurve, when they are designing a vortex generator layout, they're actually looking at the operator's blades themselves and doing a really fine CFD analysis of those particular blades. And once PowerCurve identifies where VGs need to be placed to improve the AEP, what are the next steps that PowerCurve is going to be doing with the customer and their blades?
Sure. So, I think what you've said is really important. It's about understanding the real blades that customer owns and the conditions that they're facing. So, we'll take everything the customer can give us, such as SCADA data, inspection reports. We'll go out on site and take measurements if required, just so we have, the full picture of the health of those blades and what is the real geometry that's sitting out there on the tower. So that enables all the analysis and basically to come up with this customized kit for that particular blade model and sometimes on that particular site. So once we've got that kit, we'll then discuss with the operator, what is the best time to install these products. So obviously there's different climatic conditions, O&M budgets, constraints throughout the year. So we'll plan a window where we can go on site and get these products installed. And it's a pretty straightforward process once you've done that, because it's a rope access installation. So it's not going to be involving lots of other equipment or personnel on site. It's typically a 2-man team who will be up there on the ropes doing the work. So for something like a 100-meter rotor, pretty average rotor you would find in the US, you're looking at around 2 to 3 days per rotor, depending on the size of the upgrade pack, to get all of that kit put on the blade. And like I say, rope access only, you can turn the turbine on at the end of each day between the work, that's not an issue. So that process is pretty straightforward. And then the interesting bit starts, because then we're collecting the data to prove what is the percentage increase in AP. So we'll be looking at the SCADA data from the very day that those turbines have had the upgrade installed. We'll track it for as long as we need to get the statistical uncertainty down to say, what is the AP percentage increase? Give the customer the information they need to drive their business case calculations to carry on for further rollouts.
So, Nick, as we wrap up, I'm curious about the future. Obviously, all these processes and little pieces of technology, the way they're manufactured, installed, they all change. So what do you see for the future of Vortex generators? Is there any shape changes, design changes, installation changes? I mean, what's coming up next?
Yeah, really exciting. And actually, PowerCurve are involved in a couple of projects right now, R&D projects, to look at this kind of future of VGs or advanced VGs. So maybe the first thing we'll touch on is the shape of a vortex generator. So right at the very start, I said, if you've got something sticking into the flow, it's probably going to create a vortex of some form or other. And over the years, the industry's kind of converged on these little triangle shapes. You see them on aircraft, boats, cars, wind turbines, and they all pretty much look the same. And that's because they're fairly straightforward to analyse, they're quite nice to manufacture, so they've got some momentum. However, like anything, if we start to optimise, we're trying to squeeze every last percent out of a turbine, we're going to need to look at the shape of those VGs. So things that look a little bit more exotic, they're a little bit more curved, have different form factors, I think you're going to start to see vortex generators that aren't fitting this traditional triangular shape. And I was actually testing something in the wind tunnel a couple of weeks ago. We think we can see maybe a 10 or 15% lift to drag ratio improvement over a standard triangle. And that's really exciting because that could translate into a few tenths of percent AP. So, and it's for free. If you're going to put the VGs on, why not put on the ones that give you even more performance? So, I think a few shape changes definitely overdue, in my opinion. I think the industry has been a little bit boring, for want of a better word, in terms of pumping in a bit of money into some more exciting geometry. I think the second thing is probably installation-wise. We're seeing more and more, and you've had some great guests on your show about robotic processes, whether it be measurement or repair, helping technicians on the blade. There's all kind of devices starting to mature. So I get really excited about, maybe pairing up a rope access team with a robot or a drone that can actually make the process quicker, safer, more efficient. So maybe you get your drone marking up the blade where the VGs could go, the rope techs follow it down. Maybe a little bit further down the line, you can imagine a slightly different VG design being a bit more compatible for a drone to actually go up and stick on the blade, or one of these ones, crawling robots that could roll out and put some VGs on the blade. So particularly in the offshore market, there's a real focus to get people away from the turbines. No one wants to be hanging from a rope 300 foot above the North Sea. So I think this is going to have some attention, and like other O&M activities offshore, you're going to start seeing add-ons becoming kind of part of the portfolio for robotics and other autonomous devices going out there and helping with these processes.
Well, I like the idea of the alternate shapes. Maybe you can even do seasonal shapes. Like, it's Halloween coming up. You get like a spooky ghost on one blade.
You know what? Yeah, I mean, that's pumpkin spice latte vortex generators. Yes.
Exactly.
Yeah, why not? I mean, actually, you make quite an interesting point, because perhaps some specific climatic conditions, some specific blade shape, maybe it calls for a slightly different VG geometry. Again, the fact there hasn't been this mass investment in CFD, wind tunnel testing, all these things regarding add-ons, means there's all kinds of optimization paths available. There's no reason why they should all look the same. There will be optimization potential. It's just what's that cost benefit analysis, and I'm hoping that in the coming months that I'll be able to maybe come back on the show and show you some of the cool shapes we've been working on at PowerCurve.
Well, and we've also talked in the past about, as cost and manufacturing gets easier and comes down, that it might be more advantageous to potentially install, like a PowerCurve upgrade that only lasts maybe 5 years instead of 10 years, or only a couple years, because you say, hey, let's just do, and these are more inexpensive, easier to install because of robotics or whatever. So now we can revisit this and see how the blades changed in a couple years and maybe install new, better optimized ones down the road, rather than trying to install like forever vortex generators today. Do this saying, hey, this is inexpensive now, where we can just continue to reassess every couple of years. Do you think that's something that might make sense for this, or maybe more for other types of upgrades?
Maybe. 20 years, 25 years, the lifetime of a turbine, that's a long time for R&D. It's a long time for engineering. And there's no way that a VG design you put on today is going to be the best design in 20 years' time. It's just not. At the moment, I think the fact that you have a highly skilled like rope access crew going out and putting these on, that's quite a big proportion of a retrofit cost. So at the moment, my gut feeling is that the economics probably doesn't make sense to have something upgraded or changed, in the 5 to 10 year scope. But I think if you're able to bring a bit more robotics in, maybe that will help to push down those install costs a bit and maybe allow, a refresh or an upgrade in 10, 15 years' time to take advantage of the latest technology. You don't tend to see many other things look exactly the same for 20 years. Planes, cars, trains, whatever, they tend to have things done to them. New winglets, new VGs, all kinds of stuff. So, the big thing for wind turbines, though, is the cost. So it depends on the cost of energy, cost of install, as to whether you hit that sweet spot. And I think today we're not there, but things are changing very fast. So I think in 5 years, maybe the scene will be a little bit different.
And then before you go, there's a couple others that we just want to quickly touch on, and we're thinking of having you back on to talk about these more in depth in the future. But, there's gurney flaps and trailing edge serrations are two of the other big ones. Can you just give us a quick rundown of both of those? Because they don't get quite as much press, I think, as vortex generators do. No,
I think VGs are definitely the most common add-on out there. So gurney flap, you typically see those down in the root region of a turbine, so like the inner third of the span, something like that. For those of your listeners that way inclined, gurney flaps are often named after a person, Dan Gurney. So he was an IndyCar driver, team manager back in the 70s. So the gurney flap is named after a motorsport device. And the idea of a gurney flap is that you put it onto a blade or a IndyCar wing, whatever, and it gives you more lift for very little drag penalty. So down in the root region of the blade, we talked about this highly 3D flow, the stalled flow, thick aerofoils. Well, gurney flaps are very useful down there because they're giving you more lift where you're really kind of crying out for more lift. So they're very useful down there to give you a bit of a lift boost that translates into more torque, more AP. Trailing edge serrations, they are primarily a noise reduction feature. So I think you probably see fewer of them in the US than in Europe because of just regulatory differences. But they're the kind of little sawtooth devices you may have seen on the trailing edge of a blade. And what they're doing is they're changing the scattering mechanism primarily of how the noise is emitted from a blade. So the main noise component from a blade is aerodynamic noise. It's that kind of swooshing noise that you hear. So a serration is helping to reduce that by changing the scattering mechanism at the trailing edge, and also changing some of the boundary layer and the mixing properties. But fundamentally, they're a really nice device. They're a proven device to take, at least 2 decibels of noise off your rotor, which can be incredibly powerful. If you're running your turbine slightly lower RPM certain times of the day to cut the noise due to a regulation or something, well, a serration may help you get out of that noise mode So you get an AP boost at the same time, kind of indirectly.
Got it. That was great. Nick, so thanks so much for coming on the show. How can people follow up with you and with PowerCurve?
Yeah, thanks a lot for having me back on again. You can find PowerCurve on our website, powercurve.dk. You're also welcome to reach out directly, so you can find me, you can find my colleagues on LinkedIn if you search for PowerCurve or my name. Got a few clips out there on YouTube if you want to learn a little bit more about some of these devices. So yeah, a few different ways. Very happy to hear from owners, operators, OEMs. Yeah, we can dive into how we can best optimize their turbines.
Yeah, so definitely check out the description of this podcast wherever you're listening, and you'll find links directly to Nicholas and PowerCurve and all of their resources. So yeah, thanks again for coming on the show. Appreciate it.
Very welcome. Thanks a lot.
All right, so we want to thank again our guest here, Nick Gaudern from PowerCurve. So be sure to follow up with him in the description or show notes of this podcast, wherever you're listening or watching. Welcome to reach out to them. And again, he does a great job. We're appreciative of his time. So moving on, let's go to Germany. So we've had in the news, a Nordex N149 4500 series wind turbine collapse at a farm in Germany. And this has been reported in the news. A bunch of outlets have taken the story, but there's not a lot of information on it. Rosemary, does that strike you as odd that there's really not much out there? Is it just really early in the investigation about it, or is it really just that maybe they're not really interested in pushing out too much info?
Yeah, I mean, it's odd to me that a very new wind turbine has collapsed and in Germany and from a major manufacturer. That's odd. The fact that we don't know too much about why yet, that's not odd to me at all. I mean, I'm sure that they are trying their very hardest to keep this as secret as possible. I've got no clue whether they know by now or have suspicions about the reason, but no, it doesn't surprise me that they're not letting us know what their suspicions are.
Well, I have a question I'll kick this back to you, Rosemary. Why don't they have some sort of monitoring system, just like a webcam, that just sort of like eye in the sky kind of keeps an eye on everything in their wind farm? Why is that not kind of a standard thing, just like even like a Nest camera people have, or a Ring camera outside of their home? You
mean like security in case it was from vandals or sabotage or something?
Well, not necessarily for any specific reason, but just in general, like they can just, hey, let's go back to the tape. What happened? Did a bird actually strike at this time, or did a lightning strike at this time? Like, why aren't all these wind farms, or maybe they are, why aren't they all monitored? Like, why don't they have a tape, I guess, of this?
Yeah, I guess the reason that it's kind of like a good handy law of renewable energy, that when you ask a question, the answer is money. So yeah, maybe just like a global law. So, I mean, yeah, the answer would be money for sure, that they don't want to install all these cameras everywhere. And second, probably nearly as significant issue would be monitoring the data that you get. Although I guess you could just have it rewriting over itself until something happened and then go and look. I did actually hear about one time there was some debate about what had caused a wind turbine it was just a blade that broke. And it happened that somebody was fishing nearby and saw on their dash cam a lightning strike. So that was very handy in that case. And I guess if you were monitoring every single turbine, then you could always be sure to catch it.
Alan, what's your take on this situation? I know obviously in the aviation world, they, when a pilot goes down, there's obviously a big investigation. It seems like they make a lot of that information public. Why do you think it's so different in the wind industry? I
think because it's a lack of regulatory body to force it. On airplanes, there's a lot of instrumentation and monitoring, and they have the black box, which is recording all that data all the time. And in fact, there has been times and discussions about putting cameras in the cockpit, and that's been contentious. I don't think that's been done in all cases. I think that they're still talking about it. But I think the technology is there to definitely get video for most situations at this point, because we have so many cameras. We all have one in our pocket most of the time. So I think you raise a really good point, Dan, is that in some places, like I know in Japan, They've monitored individual wind turbines on some sites for quite a while, mostly for lightning strike reasons. Like they've instrumented them, they have video cameras watching them. That's expensive to do, obviously. But in today's world, I think you could. Weirdly enough, I think you're right, Dan. I think you could definitely monitor a wind turbine with a little camera and just let it run. And if anything weird happened, at least you have something to go back on. Yeah. Right. Yeah. You wouldn't have to keep all that much. And I think the benefit to the industry could be huge. And Rosemary, since most of the major catastrophic wind turbine events appear to be structural, wouldn't it be advantageous to have some data that we could be at least sanitized and say, hey, this is what happened?
Yeah. I mean, I always want more data, but I also know that I had this, every project that I ever worked on, I started out wanting, like 10,000 different sensors and monitoring stuff, and gradually came back down to the reality of what the commissioning crew, installation and commissioning and operational crews could actually deal with. So, it's very easy for me to sit here in my office and say, put cameras on every wind turbine. That would be awesome. But on the other hand, I know that I would never win that argument if I wanted a camera on a wind farm I was working on, that they would convince me out of it pretty quickly. So, I think there's that contrast.
Yeah, it seems like the regulatory body piece is the big one, where until someone forces them to have some sort of way to investigate and then share that info with everyone in the community, then they're not going to volunteer into that.
But I mean, no one was hurt, right? So it's not like in aviation industry where you are going to demand to know why it happened when people are injured or killed. So unless it gets that bad with wind turbines where people are being injured, I'm not sure that we'll see it.
Yeah, but one of the things we ought to consider here is sort of two pieces. The insurance agency drives a lot of that, so insurance actually drives the monitoring part of that on aircraft on some level. And I think wind turbines will be the same. But I think there's already a platform to put a camera on, which is the ping system, which is monitoring the noise of wind turbines right now. If it had a little data recorder and a little simple camera that was pointed up to the sky, and it just sat there and recorded the last 24 hours like Dan's talking about, that would be really interesting, because I think a lot of information could be gleaned out of that. That would be cool.
Or just, considering how far, like when you see these photos from like a drone, if you just put a camera on like strategically like 5 out of your, 50 wind turbines in a farm on the top of the nacelle facing rearward or whatever, you could probably get a pretty good, even if it's not up close, you could probably have a bird's eye view of your whole farm with just a couple of strategically placed ones. So maybe GoPro will sponsor, the next wind farm around here. Who knows? Or we could just strap someone to all the migratory birds, kill two. Wait, you can't say kill 2 birds with 1 stone. Oh. All right, I'll just stop there. Anyway, last article of today. U.S. Representative Frank Marvan from Indiana is advocating for the federal government to step up and provide some funding for training for wind and solar jobs, because obviously with the offshore wind boom, from the Biden administration, these are going to be fast-growing industries where people are worried that the jobs market might not be able to keep up. Do nations need to step up and maybe get away from just all the privatized educational endeavors, but also sort of like give some government programs to get people trained and to work in renewables? I
don't think so. And here's the reason why. I think in the United States, we have a community college system, which is like a 2-year training program system. And those community colleges are all over the place. And I think Dan and I were talking about this just earlier this week. Is in the United States, it's really hard to know where the training is. There are a lot of places to get wind turbine specific training, particularly in the Midwest, where a lot of wind turbines are right now. But you just can't really find them. And people contact my company all the time and say, hey, I would like to send you my resume. I'm just looking to be a wind turbine technician. Where do I go? And there really isn't a lot of information about it. But I do think there already is an infrastructure in the United States to do that. And through high school programs and apprentice programs and community colleges. And I think there's actually some colleges that have studies in renewable energy and wind turbines. That infrastructure is already there. I don't know if we need to add something on top of it. A lot of wind turbines are very specific. Like a Siemens wind turbine is not exactly like a Vestas wind turbine. And I think the OEMs have done a decent job. I know we had talked to Siemens long ago that they have a training center in Orlando, Florida, where they train people. That the wind turbine manufacturers are doing a pretty good job of training technicians on their specific turbine. That, I think, is fantastic. We should encourage that to happen because that's where you get I think you're going to get the best training is right from an OEM.
I mean, that makes sense, if for those who are unemployed, for there to be a system to like shuttle them in towards renewable energy trades. I think that makes a lot of sense. That would be cool if that could happen in the U.S. And of course, Alan's right. The community college system is a much more affordable way to get a lot of that done. But yeah, maybe there could be room for improvement there as well. So that's going to do it here today for the Uptime Wind Energy Podcast. Thanks so much for listening. Thanks again to our guest, Nick Gaudern from PowerCurve. Again, be sure to follow up with him in the show notes below. Wherever you listen on iTunes, Spotify, Stitcher, thanks for being here. And we will see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.